Good day students, myself Neeraj Rajvanshi, and today we are starting off with your math syllabus of class 11th. Today first chapter we are taking up set theory, and those who are joining my YouTube channel with this video, let me tell you what will be the method of uploading the videos and teaching in the videos. First I will complete the textbook, NCERT textbook in all my videos, and then after that I will take up the JEE matter. So those who want to concentrate only on textbook, they can see my videos only up to the textbook portion, and those who want to go for JEE preparation, they can see the videos after that also. Okay, so children, we begin with set 3 today. See children, what is a set actually? That will be the first question that will come to your mind. What is a set? So set is actually a collection of objects or articles or whatever which are well defined. Now, what do we mean by this word well defined? Supposing I say the collection of good cricketers of Indian cricket team. Now, do you think each one of you will give the same answer? Because naturally, different people have got different preferences and different likings for cricketers. So, if I ask a student A, give me 10 good cricketers of Indian cricket team, and I ask student B, it is not necessary that their answer may be same. Their answer can be different. That means the collection of 10 good cricketers of Indian cricket team is not a collection of well-defined objects, because both the students are not giving same answer. The collection depends upon their choice. That means it is relative. The answer may vary from person to person. If I ask your principal that who are 5 good students of your class, and if I ask your subject teachers, name 5 good students of this class, naturally the answer of principal and answer of subject teachers may be different. A student who is doing very good in maths will be liked by maths teacher. He may not be liked by the English teacher because he may not be performing so good in English or Hindi or whatever. That means if I am asking the teachers to write 5 good students of the same class, it is possible that different teachers may give different answers. That means again the collection of 5 good students of a class is not a well-defined collection. The 5 students, good 5 students, do not mean a well-defined collection, well-defined objects. So you have to understand what is the meaning of well-defined objects. If I give you a condition such that all the people in this world give the same answer for that collection, then only it is a well-defined collection, otherwise no. If I ask you to write down the names of 7 good colors, so you know that different people may write different names of colors. Blue, green, magenta, and so many colors are there in this world. They may write all sorts of colors according to their preferences. So that means collection of 7 good colors is not a idea of well-defined collection. But if I ask you to write the colors of a rainbow, so then all of you will write Vibgyor only: violet, indigo, blue, green, yellow, orange, red. So that becomes a well-defined collection. So you have to understand a well-defined collection will be when everybody gives the same answer. No 2 people should give different answer. If all are giving the same answer for a particular collection, then only it is a well-defined collection, otherwise it is not. If I ask you what are the multi-factors of 10, so you know there are 1, 2, 5 and 10. So if I ask anybody who is good at maths, what are the factors of integer 10? So everybody will give the same answer, that is 1, 2, 5 and 10. So that becomes a well-defined collection. Somebody who knows English, if I ask, name the vowels of English alphabet, so all will say A, E, I, O, U. Nobody will say the name of any other letter apart from these 5 letters. Therefore, this collection of A, E, I, O, U becomes a well-defined collection. If I ask you to name the rivers of India, then all are going to put the same names of the rivers in the collection. Nobody will write Nile over there or Amazon over there because they don't belong to the collection of Indian rivers. So again, if I ask you to write all the rivers of Indian country, then yes, it is a well-defined collection because all will give the same answer. We cannot have different answers from different people. Of course, they should be knowing all the rivers of India. So, if you are clear with the idea of well-defined collection, then we can proceed, and that well-defined collection of objects becomes a set. And set is written like this in braces. Supposing I want to write all the factors of 10, I will write like this: 1, 2, 5 and 10. This way I will write, and I will write 1, 2, 5, 10 with comma between them. And these 1, 2, 5 and 10 will be called elements of this set. This way we represent a set in list form, where we are listing all the elements, all the objects of the collection. And sets are usually denoted by the letters A, B, C, D, capital letters of English alphabet. So we write like this: A is equal to 1, 2, 5, 10. Or if there is a set of vowels of English alphabet, so we can write like this: B is equal to A, E, I, O and U, like this. Children, please understand that in what order you are writing the elements, that does not show the importance of the elements. If I am writing A first, it does not mean A is superior to these letters. No, that is not the point. And we can write in any order, it makes no difference. So B can also be written as E, I, A, O and U. So order of elements is not important in the set. You can write in any order. You can write any element first, any element second and so on. So in which order you are writing elements, that is not important. Also please understand, children, that no letter can be repeated, no element of a set can be repeated. No element of a set can be repeated. You will never write any element twice. It has to be written only once. Supposing I ask you, this is the word school, and I ask you which letters have been used in this word. So you will say S, C, H, O has been used 2 times, L has been used 1 time. Now if I ask you to write all the letters of this word in set form, I ask you to write all the letters of this word in set form. So supposing I call this set as A, I will write as S, C, H, O and L. Only once O will come, even though it is here 2 times. So we never repeat an element in sets, please understand. So what is a set? It is a well-defined collection of objects. That objects can be numbers, alphabets, cricketers, rivers, whatever. Sets we write in braces. Elements are separated by commas. The order of elements is not very important. The sets are denoted by capital letters of English alphabet and all those things. The letters, the elements are never repeated in the set, that I told you. Which are the set of numbers that we know? This is important, please note, children. See, these all things are given in a textbook, so you need not copy. There is the set of natural numbers, which contains elements 1, 2, 3, 4, dot, 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 like this. Children, we cannot write all the infinite natural numbers over here. So whenever a set will have infinite natural numbers, not only natural numbers but infinite objects, then we will not write all the objects. We will just write few elements, maybe 3, and then put 3 dots. Now please concentrate. These 3 dots are actually your punctuation mark, just like question mark, exclamation mark, comma, full stop, like this. So this is actually a punctuation mark, just like your question mark and apostrophe and all those. And this is called ellipsis, which means omission or continuation. Omission means if I want to omit the rest of the numbers, then I am writing only 3 dots. Or if I want to show continuity with the same pattern, then I am putting 3 dots. So ellipsis word means omission, or we say that it is continued in the same pattern. This is the meaning of 3 dots. So 3 dots are a special symbol, which is a punctuation mark, which means ellipsis. Ellipsis means omissions or continuation. So children, don't put 4 or 5 dots over here. That is wrong. You have to use this punctuation mark only to show continuity. This we have been using in your AP in class 10 when you studied sequence and series. You are being shown, you are given a sequence Fn. It used to be like this: 1, 4, 7, 10, and then 3 dots used to be there to show continuity. Then will come 13 and 16 like this. So there should be only 3 dots. This is a particular punctuation mark called ellipsis. So don't put 4 or 5 dots according to your wish. That will be wrong. Use proper punctuation mark. This is the punctuation mark. Okay. So n is represented like this. This is the set of natural numbers. Then we have a set of whole numbers, if you know. That goes like 0, 1, 2, 3 and dot, like this. This is set of whole numbers. That means this is set of non-negative integers. This is set of positive integers. This is set of non-negative integers. Non-negative means other than negative, means either 0 or positive. Children, learn to use proper terminology because now you are in class 11th. If I ask you what is the square of a number, you would say square of a number is always positive. But what is square of 0? That is 0, that is not positive. So that means square of a number is always not positive. So square of a number can be 0 or positive. So how do we combine these two words, 0 or positive, by saying non-negative? Non-negative means either 0 or positive. So henceforward, please say square of a number is always non-negative. Don't say positive, that will be wrong. Because square of 0 is not positive. Square of 0 is 0 only, which is not positive. So please learn correct terminology from now on. Please say that square of a number is always non-negative. Okay, so this is set of whole numbers, non-negative integers. Then we have z, which is collection of all the integers, 0, plus minus 1, plus minus 2, plus minus 3 and dot, 3 dots, like this. Set of integers. Then we have set of rational numbers, you must have studied in class 10, which is in the form of p by q, such that p is an integer, q is an integer, q is not equal to 0. Children, this vertical bar means such that, and in sets we can write a colon also. This is a colon. This is a semicolon, and this is colon. So we can use colon over here, p by q, such that p belongs to z, q belongs to z, but p and q are integers and q is not 0. This symbol that I am using, p belongs to z, this symbol is epsilon, or sometimes they call epsilon also. So this symbol is used for saying belongs to. Belongs to means p is a member of set z and q is a member of set z, like this you have to think. So this symbol is belongs to. P belongs to z means p is a member of set z. P is an element of set of integers. So p has to come from here, q also has to come from here, but q should not be 0, because once I say q is a member of z, that means q can be 0 also, but something upon 0 will be undefined. So we don't say q belongs to z, we put one more rider that q can be z, but q cannot be 0. So that is a set of rational numbers that you must have studied. So you came to know what is the meaning of symbol colon that I am using. I can use colon or I can use this vertical bar. This vertical bar is used for modulus also. We are putting 2 vertical bars around modulus. These 2 vertical bars we are using for determinants also, that you will see what is determinant. If you have seen the bridge course, in the first video I introduced you to determinants. You can first do the bridge course, then only you can come to this course. So used for determinants also, used for vectors also. If I want to show magnitude of a vector, I use 2 vertical bars like this. So this vertical bar or vertical slash has got many uses, and here when we use it in sets, it is such that. So p by q such that p is a member of z set, q is also an element of set z, such that q is not 0, that constitutes your set of rational numbers. Set of rational numbers, then we will have set of q plus will mean all positive rational numbers. Q minus will mean all negative rational numbers. Then R plus H will be the set of irrational numbers. H will be the set of irrational numbers. So what are irrational numbers? Actually, irrational numbers are those numbers whose exact value we don't know. Therefore, they are called irrational because we don't know the exact value of these numbers. Children, remember, we can plot rational and irrational numbers on number line. We can locate their positions. We can locate their positions on the number line very accurately. You must have learned in your class 10 how to plot root 2 on a number line. This is 1, this is 1. Take 1 unit, and then join this. This is root 2 by Pythagoras theorem. Take this much length and cut over here. So this much distance is root 2. So this is your fixed point root 2. So irrational number can be located correctly, very accurately on a number line. But we don't know its exact distance from the origin. We can't measure exactly the distance from origin. Therefore it becomes irrational. So irrational number can be accurately pointed out on a number line. Rational number also. But only thing is that rational number cannot be expressed in the form of P by Q like a rational number. So we call it irrational. And then we have got the set of real numbers, which is made up of all the rational numbers and all the irrational numbers. So this becomes Q union H. Union, what is union? We will see later on as we cover this chapter. Union means it is a sort of addition of both the sets, elements of both the sets. So all the elements of Q and all the elements of H combinedly, they will be put in the set of real numbers. And please remember, whatever is a rational number, that cannot be irrational, and a number which is irrational cannot be rational. That means these two sets cannot have any element in common. These two sets, set of rational numbers and irrational number, they cannot have any element in common. There can be no real number which is irrational as well as rational. And combinedly, Q and H form the entire set of real numbers. So this was introduction to the sets of different numbers. You know what will be R, the set of all the real numbers, and therefore what will be R plus, set of positive real numbers, what will be R minus, set of negative real numbers. Remember, 0 will not be included over here and 0 will not be included over here because 0 is a neutral number, neither in positive nor in negative. Okay, so after this, I already told you what is the meaning of the symbol belongs to. Okay, so now we are in a position, after understanding this, we are in a position to do exercise 1.1. So I take before you exercise 1.1 and I'll take a few sums from there. Then we can see. See which of the following are sets. I will give you a collection of objects and you decide whether it will form a set or not. The collection of all the months of the year beginning with letter J. So all the months of the year which begin with J. So it can be January, then June, and then July. So any other month beginning with the letter J. See January, February, March, April, May, June, July, August, September, October, November, December. So only January, June and July. So all will give this answer only, January, June, July. Nobody will give any other answer. Therefore it is a well-defined collection. Therefore it is a set. A collection of 10 most talented writers of India. Now 10 most talented, again different people will give different answers. So this is not a well-defined collection. A team of 11 best batsmen of the world. 11 best batsmen of the world. So again, all will not agree upon a certain set of people only. Different countries will give preference to their batsmen and therefore all are not going to give the same answer. Therefore this is not a well-defined collection. A collection of all the boys in our class, yes, that's a well-defined collection. So this becomes a set. Collection of all the natural numbers less than 100. All natural numbers less than 100. So from 1 to 99. All will give same answer. Nobody can give a different answer. Therefore it's a well-defined collection. A collection of novels written by writer Munshi Premchand? Yes, that is a well-defined collection because we can find out which novels have been written down by Munshi Premchand. So that becomes a well-defined collection. Collection of all even integers? Yes. 2, 4, 6, 8, 0, 5, 8, 10, 12. This is a well-defined collection. Collection of questions in this chapter? Yes. We know what questions have been asked in this chapter. So this becomes a well-defined collection. A collection of most dangerous animals of the world. This is again arguable because different people will give preference to different animals. So therefore it is not a well-defined collection. So a set A is given to me like this. And it is given to me that 1, 2, 3, 4, 5, 6 are the elements of this set. We have to write a symbol this. Okay, right here. We have to use this symbol or this symbol. This symbol means element belongs to this set, and this symbol means element does not belong to the set. So what about 1? I will say 1 belongs to A. What about 2? 2 belongs to A. What about 3? 3 belongs to A. 4 belongs to A. 5 belongs to A. 6 belongs to A. What about 7? 7 does not belong to A. 0 does not belong to A. 10 does not belong to A. -1 does not belong to A. And all those things you are having. 2 by 3 does not belong to A. Like this. Just check if the element is there, then belongs to. If it is not there, then does not belong to. It's so easy. Write the following sets in roster form. Now children, when we want to write sets, there are two methods to represent the set. One is the roster method. Please understand. See, one is the roster method. Or the list form, where we will write all the elements of the set. Supposing I am asked to write the set containing vowels of English alphabet. So list form will be this, or roster form, A, E, I, O, U. And another is set builder form. Set builder form or property method. So property method or set builder form means I will see if all the elements can share some common property. So the common property is that they all are vowels of English alphabet. So I write it as like this: A is equal to, please concentrate, X such that X is a vowel of English alphabet. I write like this, where X will denote A, E, I, O, U. X will represent these numbers, these elements. So these elements are represented by a general element X, and X is described by the property of all these. What is the property? That they are vowels of English alphabet. So write X such that, or I can use colon symbol also. X is the vowel of English alphabet, like this. If supposedly I have got a set B which contains elements 1, 2, 3 and 6. So this is the roster form. If I want to write in property form or set builder form, I will have to identify property of all these elements. So I can see these all are factors of 6. So I will write B is equal to A such that A is a factor of 6. I can say like this. So for general representation, I can use a symbol X or Y, Z, A, B, C, whatever. Please understand. If I got a set C like this, having elements 2, 4, 6, 8 and 10. So I will have to look for the property if I want to write this in set builder notation. I can see these are even integers, positive even integers, less than 11 or less than 12. So I can write C is equal to Y such that Y is a positive even integer less than Remember children, whatever property we are writing over here in set builder notation, that property should be satisfied only by these elements and by no other element. So if I write y is a integer less than 11, even integer less than 11, so I may use negative numbers also, -2, -4. So this will be wrong. So I have to write positive even integer, so that only these numbers are having this property. So when we are writing in set builder notation, when we identify the property, we have to make sure that this property is satisfied only by these elements and not by any other element. So I told you about list form and property form or the set builder notation. Now children, these sets that you are seeing, this is having 5 elements, this is having 4 elements and 5 elements like this. If I want to write integers, positive integers from 1 to 10, then there can be a set like 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this set contains 10 elements. All the letters of English alphabet, that will contain 26 elements. And like a set can contain any number of elements. If the set has got definite number of elements, it is called a finite set. F-I-N-I-T-E. Finite set. Its number of elements will be fixed, will be definite, will be certain. They can be however large, but they are definite. And infinite means we don't know how many elements will be there in that set. Like the set of natural numbers, we don't know how many elements will be there in that set. They are uncountable. What about the leaves on a tree? Are they infinite or finite? Now you have to understand a difference between finite and infinite. See, I am telling you finite means which are definite. They can be however large. But infinite means we should not be in a position to tell the definite number of elements. Now the number of leaves on the tree are very large, but they are definite. They are not infinite, they are not undefined. Once we start counting the leaves, it will stop somewhere. So the number of leaves on a tree are definite. Yes, they are large, they are very large number, we agree, but they are fixed. What about the number of hair on your head? They are very large number, but you can count the strands. So they are finite. What about the number of stars in this universe? They are very large, but they are not infinite. We have fixed number of stars, around 10 to 22. So they are not infinite. So understand the difference between infinite and finite. Infinite means we don't know the exact number. Finite means we know the exact number. Now that exact number can be very large, it can be any amount, that is okay. But if you know, we can count, we know what is the number of this, then it is finite, otherwise it is infinite. So I told you about this roster method, or which is also called list map form, then set builder form or property method. So going on to this question, it is being told, write the sets in the roster form. So A is given to me as x such that x is an integer and -3 less than x less than 7. So what are the elements between -3 and 7? It will be -2, -1, 0, 1, 2, 3, 4, 5 and 6. This is list form of this method. Then there is a D. I am not doing all, remaining are easy, you can try out. It is said that x such that x is a prime divisor of 16. Now we don't want divisor only, we want prime divisor. Divisors of 60 are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30 and 60. These are factors of 60. We want prime. So we can take this, we can take this and we can take this. Remaining all are composite numbers. So what will be the list form of this? This will be 2, 3 and 5. Like this you have to think. So, like this about listing form, you can carry out the remaining ones, children. They are very easy. Let me not waste time, but in each and every one, wherever tough sums are there, I will try to do all the sums. Question number 4 is write the following sets in set builder form. So I am having a set A, which is 3, 6, 9 and 12. So I have to identify the property of all these elements. I can see the properties. These all are multiples of 3, but they are less than 13 or 14 or 15. So I will write X such that X is a positive multiple of 3 less than, I can write 13 or 14 or 15. It will be up to 12 only, like this. Then I have got a set B which says X such that I am having elements like this: 2, 4, 8, 16 and 32. So I can see these are all our powers of 2. 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5. So I write it as X such that 2 raised to X and X should be less than 6 and X is a natural number. So X less than 6 and X is a natural number, means X will be only 1, 2, 3, 4, 5. I will put 1, 2, 3, 4, 5 here, I will get these elements. Children, you have to be very specific. Don't write only X less than 6. X less than 6 means X can be 5.5. Now if I put 5.5, I will not get elements over here. So you have to be very, very specific when you write the property method, the set builder notation. Then I have got 525, 125 and 625. We know these are powers of 5. So what am I going to write? X such that 5 raised to X. X is a natural number. X less than 5. So X can be 1, 2, 3, 4. 1, 2, 3, 4. 5 raised to 1. 5 raised to 2. 5 raised to 3. 5 raised to 4. Like this. Then we are having, supposing set D like this: 2, 4, 6, 3 dots. So these are all positive integers continued. So I will write X such that X is a positive even integer, like this. Then supposing there is a set E, 1, 4, 9, 3 dots and 100. So I can make out these are squares of a number. So write X is an element such that X square and X lies from 1 to 10. So 1 less than equal to X less than equal to 10. So X will start from 1, it will go up to 10 and X will be a natural number. Please don't forget to mention this, because when you write X is between 1 and 10, the X can be 2.5 also, but 2.5 square is not included here. So please mention this also, very, very important. So like this, you can see that from list form we can go to property form. We have to identify the property and then write very specifically. So we saw how to convert property method, set builder notation into list form, roster form, and now from roster form we can go to set builder notation, set builder form. Few examples we took. Then we have to again list from the set builder notation. X is an odd natural number. So how do I write it, children? X such that X is an odd natural number. So we write 1, 3, 5, 7 and 3 dots. Write 3 or 4 elements and then 3 dots. X is an integer between minus half and 9 by 2. X is an integer between minus half and 9 by 2. X is an integer between minus half and 9 by 2. So if I take my number line, this will be minus half, this will be 9 by 2. That means this is minus 0.5 and this is 4.5. So which are the integers between these two? 0, 1, 2, 3, 4. So B will be 0, 1, 2, 3, 4 like this. Then C, it is said X such that x square less than equal to 4 and x is an integer. The x is an integer less than equal to 4. So children, we have to think of all those integers whose square is less than 4. Can we take 0? Yes. Can we take 1? Yes. Minus 1? Yes. Minus 1 square will be 1 less than 4. 2 also we can take, minus 2 also we can take. Then afterwards 3 minus 3, 4 minus 1 we cannot take because their squares are not less than 4. So by logic thinking I come to know this will be 0, 1, minus 1, 2 and minus 2. Like this. Then X is the letter in the word loyal. So loyal word is given to us and we want to write its letters. So I will write L, O, Y, A. L I will not repeat, I told you before also. Elements are not to be repeated in the set. X is a month of year not having 31 days. So not having 31 days means it can be January not having 31 days. This has got 31 days. Wrong. February, yes, we can have. March, no, 31 days. This we cannot have. April, yes. May, 31. June, July, no. August, no. September, October, no. November, like this. Then, X is a consonant in the English alphabet which precedes K. Consonants in the English alphabet A, B, C, D, E, F, G, H, I, J, K. Preceding K means coming before K from here. And we have to pick up only consonants. So I cannot pick up A, I cannot pick up E, I cannot pick up I. These are vowels. So that will be the set F. That will be B, C, D, F, G, H and J. Like this. So, like this, and 6th question is there, that's very easy, that you can do. So today children, we have completed exercise 1.1 and we have begun with this set theory. Few definitions and few notations you have come to know how they have to use. And in each and every video, I will try to complete one exercise. Thank you children, God bless you. In the next video, we will come up with some more ideas and one more exercise. Thank you and God bless all of you.